So let's combine this knowledge here of active filters and try to figure out what kind of circuit this design is. So if we had these two op-amp circuits combined, what would be our different element? And the first thing to notice is that this is a cascaded filter, so we're going to get some unique behavior by cascading them. And we can look to see where the capacitors are in each of the circuits to figure out what type of filter it is. This filter in sort of stage number 1, so let's call this sort of stage 1 filter, this has the capacitor in the feedback loop, and so this will be a low pass filter. And the circuit over here on the right, it has the capacitor in the source, and so we will call stage 2 right here, so stage number 2, this will be our high pass filter. And again, for each of these filters, their gain is going to be negative RF over RS. And then their frequencies, their corner frequencies, whether low pass or high pass, is going to be 1 over RC. And it depends on which particular type of filter, whether we use the ones in the feedback or in the source loop. So for a couple values, let's say on this low pass filter here that RS over here is 1K. RF is going to be 10K, and our capacitor will be 9 nanofarads. And so if we're to plug these values in here, we would get negative 10K over 1K, and so we should expect a gain of negative 10 from this particular circuit. When we look at our low pass, our cutoff frequency, because this is a low pass filter, these are going to be the parameters that are in the feedback loop, and so that's going to be 1 over 10K times 9 nanofarads, and that's going to end up being 11,000 radians per second is going to be the value. And we can do the same sort of operation with our filter on the other side over here with our high pass filter. The gain on this one is going to be negative RF over RS of this particular circuit. And let's say that RS over here is 12K. The capacitor is again 9 nanofarads, and the feedback resistor is 96K. And you ask, where do you get these crazy values? The book gives you these crazy values so that all the math works out nice and easy. So 96 divided by 12 is going to be 8, and so this will have a negative 8 gain once it's done. And for our corner frequency, this is going to be our high pass filter. High pass, not high R. This will again be 1 over RC, but we're going to be using the resistor and the capacitor that are in the source loop. And so this will end up being 9.2 kiloradians per second. And so you might ask yourself, okay, well, you did it in radians, like what actual circuit is this? And so let's go ahead and plot these and try to figure out what happens. So let's say up here at 9,000, we have a high pass circuit. So here is our high pass cutoff. And then our low pass is going to be here at 11,000. So here's our low pass. So what that means for our low pass circuit, everything until about here is going to be allowed. And for our high pass circuit, everything from about here is going to be allowed. And all this stuff that's actually that's going to be in the middle is actually going to be retained. So this circuit ends up being a band pass filter. And again, this is an example of cascading filters to create more complex designs. And the gain on this overall is going to be greater than 1. So this result right here for the transfer function is going to be somewhere between 10 and 8, probably about 9 then, because our gain of our op amps. So there will not be a loss in this band, and the signals within the band will actually be amplified.